All right, let's talk about acid-base balance. Just want to preface this lecture with the amount of acid base you're going to get tested on in the first exam in medical principles is very little. It'll be very basic. I'll explain that further as we go through this lecture. But it's important to plant the seed now because we're going to spend a significant amount of time on this in pathophysiology. All right? So when we talk about the pH scale, we talk about acids versus bases. All right? Acids are something that will release hydrogen ions. The presence of more hydrogen ion within a substance or within the body, in our view, is going to cause it to be more acidic. The lack of hydrogen ions will cause something to be more basic. All right? When we talk about pH values, we're going to talk about on a normal pH scale and then within the body as well. All right? So anything less than 7 pH on a normal scale, and the normal pH scale is considered acidic. Greater than 7 is considered basic. All right? So here's your pH scale out of your textbook. You'll see that 7 is a neutral pH, and then lots of other substances that you come into contact with every day on both sides, and some that you don't come into contact with very often, like hydrochloric acid. Hopefully you don't, right? But oven cleaner and bleach, you'll see that those are extremely basic and that you will come into contact with those quite frequently. So, question being, what is the normal pH in the body? We covered this briefly before in one of our other discussions when it came up, but 7.35 to 7.45. What have I said about bolded, italicized, and text that's in a yellow font in my lectures before? Yep, you'll probably see it somewhere else, okay? So know this 7.35 to 7.45, all right? So acidosis versus alkalosis. Big point right down here to begin with, your body's always trying to maintain homeostasis. Homeostasis is defined in many different avenues as far as the specific body processes. When we talk about acid-base, it's always trying to maintain a pH balance of between 7.35 to 7.45, all right? If your pH is under 7.35, you are said to be in an acidotic state. You're in acidosis. So your body has too much acid in the form of hydrogen ion and is unable to buffer. We'll talk about those buffer systems here in a second. If your pH is over 7.45, you're said to be alkalotic or in an alkalosis state. Your body has too little hydrogen ion and is unable to buffer. All right. Now these are sustained, and you can have certain medical emergencies, and I've got a couple examples of those here in a second, where it can be reversed quickly with the adequacy of a buffer system. Now, what do we mean by a buffer system? That's a system within your body that helps regulate the pH through different mechanisms, all right? These buffer systems, you're not going to get tested on right now. We're going to spend a lot of time on that in pathophysiology. But your respiratory buffer system, if you blow off CO2, that'll lower your pH. Conversely, if I hold onto my CO2, that will raise my pH, okay? Excuse me, I think I said that incorrectly. We've got a typo here. Body blows off your CO2, okay? That will actually raise your pH. I do need to make that correction, I'm sorry. So if I have less acid, that will raise my pH, okay? Your renal buffer system, when your kidneys and your nephrons are filtering out what's coming through them and saying, okay, we got to get rid of this, this goes back in the body, so on and so forth. In the presence of more acid, more hydrogen ion, your renal system will actually retain the hydrogen ion and eliminates that through urination, okay? Now also your pancreas plays a role in that it produces bicarbonate, all right? Your pancreas produces bicarbonate for a couple different reasons. Number one, your GI system, especially your stomach acid, is extremely acidotic, so it needs to neutralize that as it goes through the GI system. specifically that small intestine. Also, the kidneys can release bicarbonate into the serum and also excrete it or regulate the amount of bicarbonate that's being put back into your body as well. And we'll talk about how all of these systems work. It's a little confusing, but they're all working in a concerted effort, and if one breaks down, the other one will try to make up for that, okay? Now, let's show you a couple different examples, all right? So, first one, with this one, just gonna let you know that there's some strong language in this. So just to preface that, and I'm going to turn the volume down once again. Give me a second here. All right, here we go.
They got needles on their legs.
Yeah, they got needles on their legs.
Is they alive?
Yeah. Pop the rock.
All right, so as you can see, this is an opiate overdose. We've probably all seen these before. But what I want you to notice is the respiratory rate of this person right here.
Hey,
She got a cigarette burning in her hand, y'all. Put the car in gear.
put the car. Put it in park. Put it in park.
Hey, they said don't touch it. They said don't.
All right, as you can guess, she's not breathing. So what's happening? Do we have an increase in CO2 in our body? How is this any different than you forcefully holding your breath? It's not. Eventually, though, you're going to get to a point where you can't hold your breath any longer and you're going to start breathing. This person, because of the pharmacological agents on board, doesn't have that option. So, is she acidic or alkalotic? Hold your breath. Does your pH go down or up? It goes down because the presence of CO2 acts like an acid in your body, and that will actually lower your pH. All right? Now, conversely, let's say you've got a patient like this.
Remove all the instruments from me now.
I can't breathe.
Are you okay, Mrs. Flossmore? I need you to slow
can't
down
feel
your
my
breathing
fingers.
for me. Try to breathe through your nose. I want you to breathe slowly, slowly. Come on. Just concentrate on your breathing for me. I want you.
Some pretty rapid, deep breathing, isn't it? What's happening to this patient? She's blowing off a lot of her CO2. So if we know that we are not breathing fast enough, we're not breathing deep enough, we're retaining CO2, well, what's the opposite? If we're breathing too fast and too deep, we're getting rid of too much CO2. And what happens to our pH? It goes up, all right? Because remember, the presence of CO2 will act like an acid within your body and will lower your pH. So if we take away all that CO2 or take away a lot of it, it does the opposite effect. It raises your pH. All right? Some very basic concepts that I need you to grasp and understand. That's really the extent of our acid-base introduction. Trust me, there is plenty more of this to come with pathophysiology, and I want you to go ahead and submit 2 questions, as always, to the assignment board within Blackboard, and we'll talk about those in class.